Welcome back to Underground Storage Tank Compliance. And I'd like to thank you all for being here. We're into Tanks 301 this section, and as it should be, we're getting a little bit more complicated with our topics and the how to understand underground storage tank compliance. So we've gone through the first two sections of tanks. We've talked about how to create tanks, how to make tanks, tank manufacturers out there, the warranties. Now we're going to get into the monitoring of tanks for leak detection. So since 2015 has already come and passed, we're not really going to talk about the older methods of leak detection. We're not going to cover the CSLDs or the SIRs, or if you don't know what those mean, we're still not covering them. I may cover them in one of the later topics as we get into extra topics, but since the new regulations are in effect, we're going to really just talk about what those regulations entail for you to do with your tanks since April 2016. So in 2015, they updated 40 CFR 280, which are the EPA's underground storage tank regulations. And since then, there's only one legal method of tank leak detection. It's secondary containment with interstitial monitoring. Californians had this on their books since 2004, and they refer to it as VPH, which stands for continuous vacuum pressure or hydrostatic monitoring. And I'm going to talk a little bit more about what each one of these different kinds of interstitial monitoring are. So when you talk about interstitial spaces, what we're talking about is the space between two tanks. So for a double wall tank, that's the primary tank and then the secondary tank. You can have triple walled systems, you can have quadruple walled systems, you can have pretty much any amount of walls that you can manufacture. What you don't see a lot of is anything beyond double walled tanks anymore. Double walled tanks are regulated by EPA. You have to have double walled tanks now. That's what you have to store your fuel in whenever you're working under 40 CFR 280. You could use triple wall tanks. Triple wall tanks can be used for very, very hazardous substances or in areas that are very ecologically, could be threatened easily. They're sensitive areas that if fuel gets out, it would really cause damage to the environment and to people in the area. You'll see a lot of these protected areas. They may require triple wall tanks. If you're storing very, very hazardous substances like cyanide or something, they could require you to use triple wall tanks. You don't see it a lot, but they do exist and they are made out there. As we talked about earlier, you have double wall fiberglass tanks. When you're putting the tanks in the ground, you can see on the end DW for double walled, or they'll say double wall on them. So you know these are double wall tanks. We talked about how Xerces and CSI tanks are made. These are double wall steel tanks. You have your primary inner tank, your secondary tank on the outside that's non-corrosive, and that'll serve as your secondary containment for the interstitial space. And this is just a little diagram of what it looks like inside your tanks whenever you're talking about your primary tank. That's the internal tank here, and your secondary tank's the outside tank here, and the space between the two, that's your interstitial space. You'll hear that called annular space sometimes from people that have been in the industry a long time, but all the regulations refer to it as interstitial space now. So interstitial space is pretty much what we're going to use throughout this. For a steel tank, you have this riser coming down to the bottom of the tank, and that can either hold a sensor in there that will go into an alarm if any liquid touches it, or on older systems you could actually lower something down there, a baler or a stick or water finding paste on a stick, and you can look and see if there's anything in there that way. That's not really accepted for the new regulations, but it's something that you can see on old systems. In fiberglass tanks, you have a sensor. These are dry interstice. So dry interstice is just basically an empty interstitial space. So there's nothing in there, and you'll put a sensor all the way to the bottom of your tank. And fiberglass tanks, it goes around the actual wall of the tank. to the bottom, and they're very, very difficult to get in and out. I've heard a lot of contractors and technicians complain about how hard these things are to get in and out of here, and they have to be tested annually. So they have to be put in and removed periodically to be tested to make sure that they're functioning. Sometimes you'll have to tie a string or a rope or something on the other side of it so that you can pull it back through, and a lot of times those strings and ropes rot away or break and they won't work anymore. So then the contractor has to find another way to get these sensors all the way down to the bottom of the tank, and it can be quite labor intensive and difficult for these guys. In a steel tank, like I said, you can have the riser on the end and then just put a float all the way to the bottom of that. And so the sensor has to rest on the bottom of this, and if it gets wet, it goes into alarm. It's pretty simple. These are the different kinds of interstitial space we discussed a little bit earlier. Empty space, which I was just talking about. Hydrostatic, which is some form of liquid in there that you put in the interstitial space, or a vacuum. Or there's also pressurized systems where they pressurize, and the pressure and the vacuum are pretty similar concepts. They do kind of the same thing. And I've seen vacuums overseas mostly. Our European sites, or even those over there in the Pacific area, they use a lot of vacuum systems. Here's just some diagrams of the different interstitial monitoring. You have the dry annular space with the liquid sensing probe at the bottom. So what you'll have is with a dry interstitial space, it can be a little challenging at times to make sure it works properly. All this sensor does is go into alarm if it gets wet. So if you put a tank in the ground and there's no groundwater in the ground, you could have a leak on the secondary tank and it would never set this off because there would be no liquids get to it. But if you had a leak on the inside tank, it's supposed to, by the mechanics of it, drain down here to the bottom and set this into alarm. What you'll find is a lot of our sites across the country, if they're in a very dry region, this may not be a practical approach. Even though a lot of the tank pits act as big bathtubs, because the tank pit is usually made of a porous material like sand or pea gravel, and if the soil surrounding it is a lot more compact or less porous, then it will act like a big bathtub. So you'll have basically parched groundwater surrounding these tanks, and then this would work fine because water would drain from the outside into the tank and set this off, and you would know you had a problem with the secondary tank. Dry locations, that may not work so well. Here's another diagram of what the sensor looks like in the bottom of a dry interstitial space. Vacuum monitored interstitial spaces, what they're doing for the most part is the whole thing is vapor tight, and they're using the mechanics to influence a vacuum on the interstitial space. And all you're looking for when there's a vacuum in is you want to see if this light's green. If that light's green, then you have no problems. If any other things are on, if it's red or yellow, then you've got to get a contractor out, a technician, to check out what's going on to see if there's some kind of vapor leak or liquid leak in the system. And here's what it looks like in a normal operation. You look for the green light, you have airflow here, you have measuring line here, then you have the interstitial space. So it's being monitored 24/7. There's a gauge showing you that the vacuum is in place. There's a pump, so it's under pressure all the time, and the same concept is used for the pressure system, except for it's pushing instead of pulling. Basically same thing. So if you have a leak in a vacuum system and it's above the liquid line, then you're going to be pulling air, and the system will notice that there's a change in the vacuum and it'll go into alarm. And it's the same for the outer tank. If the outer tank has a leak and there's no groundwater around it, then it's pulling air, and that'll go into alarm too. So you'll have the alarm, and it'll tell you that you've got a problem. You need to get somebody out to look at it. This is the same system. If it has a leak on the primary tank below the liquid level, then you'll get liquid in the interstitial space, and that'll cause a change in the pressure for the vacuum, and you'll get an alarm. If you have it sucked up, it goes up until it hits there, then it sets off the alarm. And this is just another way it shows you. And it would be the same if you were in a groundwater. If the groundwater went above a certain point in the tank, then that would be pulled into the interstitial space, and that would go up. And the same thing, it would cause it to go into alarm. So here you can see all these things are in. And if you want to read any of these, you can just pause the video and read whatever they say. And I pulled these from another website, and I'll put the link to that website on here in case you want to go look at more information. So it's called Class 1 leak detection, and it's defined by European Standard EN 13160-2. And it's just, they put the system under vacuum. And this also connects to the piping. So the piping and the tanks are all under vacuum at the same time. So the whole system is being monitored by that vacuum. This is what we call brine monitoring or hydrostatic monitoring. So in hydrostatic monitoring or wet monitoring, the interstitial space is filled with a liquid, and it's usually a brine solution that won't cause your tanks to rust, that won't freeze if the temperature drops low enough that it could affect the brine solution. And it just surrounds that area so that anytime there's a release that changes the level of the brine solution. So up here, this is called the reservoir, this area up here. That's usually supposed to be set to a certain point inside this area where it can move a little bit due to temperature fluctuations, but it shouldn't move very much. And if it does, there's a sensor in here, a float, that it will move, and then it'll set it into alarm if that float moves. So in the normal conditions, everything is stable and stays where it is. The liquid will stay where it is, and it never goes in alarms. The only thing you're looking for on your automatic tank gauge is that this sensor shows normal. That's the only thing it ever indicates on the automatic tank gauge is normal. So as long as it's normal, you're in compliance. So if there were to be a leak, say on the outside, the secondary tank, then your brine solution would drop. It would cause this sensor to go into alarm, and then you would call a contractor out to come out and assess the situation. And they would probably more likely try to put brine solution in here again, and if it keeps dropping, they know they've got to release to the outside. This can also happen if you've got a high groundwater, then it'll still drop to the height of the groundwater. And here's another picture with the groundwater level, but it'll only drop to whatever that high groundwater level is. So it still drops, but not as significantly as it would if there was no groundwater. Now, if the groundwater level is higher than the reservoir, it'll cause the liquid level to go up inside the tank, inside the reservoir, and that'll cause an alarm to go off too. Now, there's a caveat to that, and we'll get to that in just a minute. So if the primary tank wall is breached, you will have fuel either getting out into the brine solution, but most likely what will happen is the brine solution, the level will drop because the head of the brine solution is higher than the fuel in the tank. So since it's higher, that means there's more pressure. It'll push it down, and it'll come out into your fuel, and all of a sudden you'll start getting water alarms in your fuel. If you get water alarms in your fuel, that could mean that you've got a brine leak from your interstitial space. So any water alarms, hopefully your automatic tank gauge or whatever you're using to monitor your tanks is set so that if a water alarm goes off, which is usually around set to go about 1 inch, go off at 1 inch or higher, if that goes off, it should shut down your whole system, because the worst thing you can do is get water into whatever you're providing fuel to, whether it's an emergency generator or a customer's vehicle or whatever your tanks go to. Water in a combustion engine is thousands of dollars, and it's horrible PR for your locations. So water is just the enemy, and it causes a lot of corrosion on the inside of your tanks too. So if there is a leak, this basically shows the same thing. It drains in the primary tank, causing the reservoir liquid to drop. You don't lose any petroleum, so you don't contaminate the environment at all. And here's what the reservoir looks like. You have, this is a dual float inside the reservoir, which have a reservoir level. What we have had happen at some of our older sites is when they installed the tanks or when they've replaced brine solution, they've put the wrong liquids in there. They've tried to use just water or whatever. So that when they do that, those levels in the reservoir will go up and down significantly. Or if the tank is not installed properly, that can also cause the interstitial space to move due to tank deflection, and it'll cause that liquid level to go up and down significantly. So sometimes a technician will come out to address high levels in your reservoir, and what they'll do is just remove, seasonally, they'll just remove some liquid from the brine, from the reservoir, and it'll cause the alarms to go off, and you'll have to do it every 6 months, because when the seasons change, it causes temperature fluctuations, or it causes groundwater fluctuations in the ground. And with the groundwater surrounding your tank, that can move the interstitial fluids around. It doesn't happen much with the newer tanks. I've seen these at older tank systems. So just be aware if a contractor or technician tells you they just had to remove a little bit of brine solution, that may be what they're having to do it for. It could become a seasonal thing. You may have to replace all the fluid out of your brine, out of your reservoir, and replace it with the manufacturer's recommended liquid so that it won't fluctuate as much. There's other ways you can fix this. One of the different kinds of sensors, there's two different kinds of sensors you can put in these reservoirs. One is a single point hydrostatic sensor, and it just goes into alarm if the brine level drops below a certain level, or basically if the brine level drops, this float will go into alarm. But if you have a dual point hydrostatic system, it has floats at both ends of this. So if the liquid level gets too high, it'll go into alarm. If the liquid level gets too low, it'll go into alarm. So with the single system, you may not get the alarms you need whenever it drops to a certain point, or it goes too high. I may have said that wrong, but you get the idea. So that's pretty much interstitial monitoring for underground storage tanks. If you have any questions about that, please put them in the comments. Let me know if you have topics that you would like covered. I try to cover a little bit every time I get a chance. I do a lot of these videos just for the nerds out there that are like me, the tank people that really want to know about how the ins and outs of these things work. So I look forward to talking to you guys again. We'll have underground storage tank compliance 401 for your tanks. That'll be the next thing I come out with. So join our LinkedIn group, sub to these videos or like them, and let me know what you think. Bye.